As part of the OpenStack Wallaby and the Red Hat OpenStack Platform 17.1 cycle, we've been asked to deliver a feature that will allow users to upgrade from Train or 16.2 to 17.1 and keep some portion of their compute footprint running on RHEL 8. The reason that you might want to do this is because you might be working with some vendor that's providing you with an application and they've certified that application for RHEL 8 and not RHEL 9. So that would traditionally block you from upgrading to Wallaby or 17.1. So the purpose of the feature is really to facilitate those scenarios where you can upgrade but leave some of your compute nodes running RHEL 8 so they can keep running that supported application. And as part of that, we also want to support the general day two things that you do with TripleO as well, like scaling out, scaling down, updates, upgrades, etc., etc. So in this video, I'm just going to go over how we've managed to implement that from the deployment framework perspective within TripleO and show you some of the changes that need to be made as you migrate nodes from, say, the compute role, if all of your nodes are in your compute role, how you'll then move, say, one of those nodes to a new compute RHEL 8 role so that it can run the RHEL 8 related stuff. So what is that stuff? Well, we're talking about containers. We really want to run. In some instances, we need to have the same RPM versions, say in libvirt. So anything that has a libvirt RPM within a container, it needs to be the same as what's on the hypervisor. So we need to make sure those containers are built on UBI 8 and running on RHEL 8 nodes and UBI 9 running on RHEL 9 nodes. So let's take a look at that now and see how this all comes together. So we switch to... So this is a OSP17.1 environment deployed by infrared. So we can see that, and we can see it's based on Wallaby. Okay, so the first thing is when you're doing that migration from, or the upgrade from 16.2 to 17.1, we have that new bare metal provisioning process. So we have the bare metal deployment YAML file, which is this one, where we now need to define all of those nodes. So this is our traditional compute role, and in my environment, this originally had 2 nodes in it. So I've reduced this to 1 now, and I've changed my instances dictionary to feature just the single compute node that I have running on RHEL 9. And then I've added this new role, this compute RHEL 8 role. So one thing that we can't do as part of this is we can't actually change the host name of the hypervisor. That's not supported by the Nova project, and it will mean that your VMs can't spawn on that node anymore if you try and change the host name. So what we've done is we've set the host name format. We can see here I changed the host name format in this case to be the lowercase representation of the role name, and then it'll have hyphen index, so 0, 1, 2, blah, blah, blah. So in the instances dictionary, because I don't want to change the host name, I'm leaving the host name the same. So compute 1, and you see that matches the schema that we initially had in our compute role. But we need to set the index, which is how Heat will refer to this when it generates all the config and it adds it to the inventory, etc., etc. We need to specify compute RHEL 8-0. So this will be the first node in this new role, and it will be our compute node. So this could be compute 75, it doesn't matter what number that actually is. You need to make sure the nodes that you put into this new group match the indexes. So we map them up to indexes like this. We set index 0 to compute 1, index 1 would go to whatever other node you have in the environment. I'll talk about some other things here. So if you wanted to do scaling, if we wanted to add another node, then we would need to specify a different image. So when we use OpenStack overcloud node provision, Ironic is going to try and use a QCal to write an image to the disks on that node. So in the case of our new role, we don't want that image to be the RHEL 9 default image. We want it to be RHEL 8. And this is how we would specify that with this image href file section here. So this tells Ironic to use this 8.4 image when it deploys these nodes. So other than that, everything else is the same. We don't need to change anything else when we do this deployment. So what we can do now is just run the OpenStack overcloud node provision. So we're going to output it to this bare metal nodes YAML file, and it's going to ask if I want to override that because I've just moved a node from compute to compute RHEL 8, so we definitely do want to override it. So we'll let this go and provision it, and ultimately it will spit out the heat environment file that we need to specify during our deployment, which will map the nodes to the correct roles. And that's how we'll ensure the right containers run on the right nodes. And we'll have a look at how containers are done once this completes. Okay, so that's finished now. So what we've done now is we've generated that bare metal underscore nodes YAML file. So if we take a look in here, we can see that we now have this compute rel 8 count of 1, the hostname format to what we made it. We can see that when we talk about the ports and how we actually reference this node, we're still using compute 1, so there's its IP address there. We have a hostname map mapping the first index in heat, which is compute rel 8 0 to the node compute 1. And that's all we need now to include in our deployment as far as the bare metal provisioning stuff goes. So we'll have a look at the answers file I'm using in this environment. So we can see that I am providing that file in there. So the next file we need to look at is our ContainerImagePrepare. So this is where the majority of logic on the TripleO site has gone into, is how we handle ContainerImagePrepare. So we can see in this case, I'm using two different registries. So my rel 8 images will come from registry proxy, and my rel 9 images will come from a QE mirror. So what we do is we set the default ContainerImagePrepare as we normally would. But when it comes to the rel 8 nodes, we prefix it with compute rel 8, or the name of the role. It could be whatever you want to call the role. This is just a role-based parameter now, like typical role-based parameters have always been in TripleO. So compute rel 8, ContainerImagePrepare, and then we set the things that are relevant for compute rel 8. So in this case, the only thing that changes for me is the tags. So we'll exit that and we'll run ContainerImagePrepare. So we're going to pass it in a roles data YAML file. So the roles data YAML file has that role, that compute rel 8 role, and we need to pass that in because we need to change some services in a rel 8 role. So we go down to our compute role. So we can see down here when it comes to Nova, we specify the Nova migration target, Nova compute, Nova AZ, Nova libvirt, Nova libvirt guest. So we need to use Nova libvirt legacy when we deploy to rel 8 because we broke things up and made them modular in Wallaby and OSP17.1. So we need to make sure we use the old format with rel 8 because that's not supported on rel 8 nodes. So if we take a look at our compute rel 8 role, see the change that I've made here is that I'm including this Nova libvirt legacy service. So we need to pass in that roles data file when we run the ContainerImagePrepare so that it can prepare the right image for that new service. And we're going to output this to containers-env. Now, I'm not caching these containers locally, so this will complete fairly quickly, and then we'll take a look at the containers-env.yaml file. Okay, so that's completed. We'll have a look at the containers-env YAML file. So we can see in here that we now have this compute rel 8 parameters, and it maps all the images that are going to be required for a rel 8 node to run. And then everything else is default, and it comes from the different registry. So we're using two different registry names. When this is published on the public registry, it'll be like RHOSP rel 8 or RHOSP rel 9 as the repositories, but here I can use two different registries with two different tags. So all we need to include is that version of the containers prepare parameter file in our answers file. So I'm including it there. I'm including the normal things other than that, and then I'm just setting an NTP server that is required for running things internally. So once we've done that, we can run the deployment. So we just run our deploy script. So from this point, the deployment will just work as it traditionally would. There's nothing really extra to report here. Once it's finished, we will be able to create virtual machines on either or. We can migrate virtual machines around. We can do all the normal things that you can do with an OpenStack environment. So once that deployment is finished, we can export OS cloud equals overcloud to OpenStack compute service list. So So we can see that we have both of our Nova Compute services working on both our RHEL 8 and RHEL 9 nodes. So we SSH to TripleO admin at 192.168.24.30 and do cat etsy red hat release. So we can see that one's based on 9.2, and then we do the same to our other node. So that one's on 8.4. We do a podman PS on the RHEL 8 node. We can see that we have a mixture of containers coming from both registries, because some things are okay to run on UBI 9 containers, some things aren't. Same thing in network agent. At least we can see that OVN controller and the OVN metadata agent is up and running on both of our compute nodes. So at this point, everything's up and running, everything's perfectly fine. So we could go ahead and create virtual machines now. It should work on both of these nodes without an issue. As I said originally, in this state, you would be able to then do your minor updates. You could remove a failed node, replace it with another node. If you need to increase the size of your RHEL 8 footprint because you need more compute capacity for whatever application you might be running there, that's supported. You can definitely do that. The only thing would be that you need to make sure you specify that image in your... Just make sure you specify the image that is different to the default RHEL 9 image. So this one here, make sure it's pointing to a RHEL 8 image. Then you can just go and add nodes to this dictionary as you would normally as part of the normal scaling. So that's basically it. There's nothing really crazy happening other than that. We basically just put most of the logic into that ContainerImagePrepare and made that role-based and made sure that the parameters were role-based parameters so that we can specify the compute RHEL 8 for anything that needs to apply to a RHEL 8 node. One of the things we've been discussing is setting the machine type in Nova, for example. So that's also a role-based parameter. You would do compute RHEL 8 parameters and then put in the hardware type that you want to specify. And that will help with migrations and running virtual machines with the compute type that's used by libvirt underneath. So if you have any questions, feel free to reach out. I'm happy to have a chat, discuss various aspects of this. The upgrade component is still being worked on, still a work in progress. We'll try and get a demo out for the upgrade process as well, because I know a lot of people will be interested in that, since that's how we arrive in this state. So just to clarify, this is a supported thing for upgrades only. We don't want to advocate for deploying into this state for a greenfield deployment. You don't want to have a mix of RHEL 8 and RHEL 9 nodes if you can help it. Our main goal is to support those use cases where you're coming from an older version to a newer version, but you still need to run some of those legacy workloads that you might have. So yeah, if you have any questions, feel free to reach out. I'll leave some links in the description below for some of the stuff we've talked about and some of these example files as well.